Good afternoon, everyone. Once again, I'm sorry I couldn't be here today. I'm going to make this video because I can't ensure that you're going to have a math teacher available as a supply, and I don't want us to fall behind the other class. Okay, so hopefully this doesn't take too long as a video. If you have any questions when the video is done and you're doing the practice work, Mr. Steele and Miss Yake will be in the math office, and you can always feel free to ask them for help. Okay, determining the domain and range of a function. So we've already kind of talked about domain and range. The domain is the set of all possible values of the independent variable. And we need to remember that the independent variable are the x values. The range is the set of all possible values of the dependent variable, which are the y values on a graph. Good. A couple definitions, number sets. So natural numbers are counting numbers. So if I asked one of you to start counting, you would probably say 1, 2, 3, 4. So that's what natural numbers are. 1, 2, 3, 4, etc. If we were to use these in domain and range, they would be represented by a capital N. The whole numbers are the same as counting numbers, but we're including 0. Okay, so they have no decimals. And they include 0. So 0, 1, 2, 3, 4. And those would be represented by a capital W. We're not going to use all these acronyms, the N, the W, but just in case you see them somewhere in the future, then you know what it's talking about. Integers are whole numbers that are positive or negative. Okay, so it could be -2, -1, 0, 1, 2. And weirdly enough, they are represented by the letter Z, not I. And finally, real numbers are just every number. It can include decimal, it could be a fraction, it's everything. This is the one that we use in our domain and range, the R. Remember the XER, the YER? We use real numbers. Okay, so just as a quick refresh of those, natural numbers, 1, 2, 3. Then we have whole numbers, which are the same as natural numbers, but we're adding 0. Then we have integers, which is all whole numbers, but you're doing plus or minus. And then finally you have real numbers, which is everything. Good. Okay, so when we're looking at functions and we're trying to determine the domain and range, again, we know that we're going to start our domain with XER. We're going to start our range with YER. And then we need to figure out if there's any restrictions. So this first one is a linear line. Linear lines can go to positive infinity or negative infinity. There are no restrictions for domain, unless it's a word problem and it tells you otherwise. Like obviously you can't do negative times, so there would be a restriction at 0. But in this case, it doesn't give you any other information, so we just leave it at XER. And it's the same with the range with linear. It can go as high as possible or as low as possible, so we leave it at YER. Okay, the second one, quadratics, right? It has this exponent of 2. This is in factored form. So domain and range are the easiest in quadratics in factored form because of 2 parts. Okay, and I know that it's been a while since you've looked at quadratics, and I'm not expecting you to remember everything and how to graph this, but you do need to know this, that, sorry, the negative sign here is telling us that when you draw a parabola, you'll be opening down. Okay, so that means that y's are all going to be less than a number. The only other thing we need to look at is this. That is your maximum or minimum value. And that's telling us that y's are going to all be less than 6. Okay, so those are the two things. The negative sign at the start means it opens down, so y will be less. The 6 at the end tells you that the y's are less than 6. If that negative wasn't there, then it would say y is greater than 6. Okay, so in terms of our domain and range, again with quadratics, if it doesn't list a restriction, XER. You can sub in any x value into that equation and get an answer. But the range, that's what we just worked with. We have a restriction, and it is y is less than or equal to positive 6. Okay, this last one. This is called a radical. It's in a root sign. The thing we need to know about roots, and we kind of talked about it on Wednesday, is that you cannot have a negative root. If you go on your calculator and type in any negative number, so let's pick -4, the root of -4 is error. You cannot root a negative. So that means our x values that we're going to plug into here cannot end up being a negative number. So for example, if I plug in 1, well, 2 minus 1 is 1. That's positive, so we'll get an answer. But if I plug in 5, 2 minus 5 is -3. Can't do that. Okay, so the domain, again, we start with our XER, and the restriction here is x has to be less than or equal to, in this case, 2. We can do the root of 0. So whatever number you're given here, that's what the number that you're going to work with in your restriction. 2 minus 2 is 0. The square root of 0 is 0. Okay, is there a restriction on our range? When we get into transformations, we'll look at it more closely, but for now, let's just say that there's not. Okay, next question, a word problem. You have 24 meters of fencing to enclose a rectangular garden at the back of your house. So let's stop right there. It says we have 24 meters of fencing. So that means we have a perimeter of 24. So if I draw the rectangular garden, we know we have length and width. Okay, and the formula for perimeter is 2 length plus 2 width. Okay, it wants us to express the area of the garden as a function of its width. But we're only given perimeter information, so we need to use this information to isolate a variable and then put it into an area equation. So because we want the final answer to be as a function of width, we're going to isolate the L in the perimeter, because that leaves us with the W later on. Okay, but first thing, the only information we know here is the perimeter. It's 24, so we're going to put that here. Okay, I want to isolate the L, so I'm going to subtract 2W from both sides. So I end up with 24 minus 2W equals 2L. And from there, I'm going to divide everything by 2. And that means L equals 12 minus W. Okay, so all the L's in this rectangle mean the same thing as 12 minus the width. From there, we can figure out the area. So area is width times length. Okay, but using substitution, we can take what we know L is the same as, and plug it in. So now area equals width times 12 minus W. Good, so there is the area function for width. Now we have to determine the domain and range. So if we were to distribute this formula out, this equation out, we would get quadratic, right? That W times negative W would give us negative W squared. So we know it's quadratic. If I was to show you a graph, and again, I don't expect you to graph yet, we'll get to that. Factored form tells us that this equation gives us two x-intercepts. A W outside of brackets means 0. And inside the brackets is 12. Okay, so if we have 0 and 12, we know that the area of this rectangular garden is going to look like that. Okay, one other piece of information that we need to know from quadratics and parabolas is that the vertex, so the very highest point, is given halfway between our two x-intercepts. So that's at 6. Okay, that's going to be important going forward. But first things first, the domain. Okay, we have our XER, and there are limitations, right? Can the width of the garden be -4 meters? No, it can't. Can it be 87 meters? No, because we only have 24 meters of fencing. So this is when you look at your graph and you realize that the X value can be anywhere between 0 and 12, right? That's our parabola. It doesn't go any further to the right than 12. It doesn't go any further to the left than 0. Okay, the range is where the axis of symmetry comes in. Okay, and our axis of symmetry halfway point was 6. That's going to give us the greatest amount of area. Okay, if the rectangular garden was a square of 6, 6, 6, 6, okay, that still gives us a perimeter of 24. We would have an area of 36 meters squared. Okay, so the range, YER, Okay, the area can be anywhere from 0 to 36. Right? Look at the y's on the graph. So we just figured out that this vertex is at 36. Our function can go anywhere from 0 to 36, and then it goes back down. So that's how we get our domain and range from a question like this. Moving on. For each relation, state the domain and range and whether the relation is a function. Okay, we kind of touched on this on Wednesday. You guys had a practice question about domain and range. And I explained to the class, when you have specific points like this, you just have to list the points. Right? There's no decimal, there's no fraction, there's nothing. Just the actual points. First of all, we look at, is this a function? Yes, each x value only has one y value. So this will be a function. And when we're listing out the domain, we don't need the XER because it's not all real numbers. It's not even a conjoining of two real numbers. It's specific points. So all of our domains are -3, -2, -1, 0, 1, 2, and 3. Right? Those are the only x's involved in this question. The range are just the y values that are given. So our lowest one is -2. And it goes up to 4. Good. Okay, this next one. So if you look closely, it looks like when x is 5, if we were to draw the vertical line, that it would touch the line twice. But that's not actually the case. Because of this empty circle here, it means that it goes right up to 5, but doesn't actually touch 5. So really, this is the only point that it touches when x is 5. Okay, so this is a function. Okay, domain. Because this can include decimals, we're going to start with our XER. We have limitations. So the lowest point for x values is right here. So -5, but it doesn't touch -5. It's an open circle. So it's not going to be less than or equal to, it's just going to be less than. The largest point we have is right here, which is 10. It is a filled in circle, so it will have the or equal to sign. Here's your domain. Okay, the range, pretty simple. There's no decimals. There's really only two values. So that's 5. This is 2.5, so I'd say it's at 2. And let's say 6. Those are the only ranges. Okay, so just in case you lost, this means does not include the number. And this means includes the number. Okay, moving on. All right, another quadratics. So we said quadratics is a function. It passes the vertical line test. Those arrows means it goes down and down and down forever and never loops back in. So there's no point on here where a vertical line would touch the function twice. So this is a function. Okay, and because those two arrows say that it's going on and on forever, there's no limitation on our x. But if you remember above, there is a limitation on our y. So we need to find the maximum value, which is 3. So all y's, because it's opening down, are less than or equal to positive 3. All right, finally, the circle. If you put a vertical line anywhere in this function, you would see that it touches twice, so it's not a function. But there still is a domain and range. And for domain and range, we just look at our lowest number in the x, which is -5, our highest number, which is +5, and you just fill in the middle. Same with the range. Okay, lowest number is -5, highest number is +5. Okay, and that's it for domain and range. If you have any questions, again, you can email me, you can ask Mr. Steele, Ms. Yake, or save your questions for Monday. Have a great